In this video, we work through the solutions to the 2022 QCAA Mathematical Methods Exam Paper 2, the multiple choice section. You can use the chapters navigation tool below to jump to a specific question or follow along to view all of the answers or solutions. For the most effective use of this video, make sure you have completed the exam for yourself before watching. Also, have your calculator ready so you can follow along with some of our calculator tips. So let's get started. Question 1. The question provides an equation for the position of a particle, and we are asked to determine the velocity when t equals 5 seconds. As the question involves a trigonometric function and determining the velocity involves calculus, we need to first check that the calculator is set to radians. The position equation is defined with t measured in seconds and position in centimetres. The question makes reference to t measured in seconds and speed in centimetres per second, so all our units match. So we're set to go. I could use the keyboard shortcut for the derivative or the maths templates, but for this example I will use the calculus menu and select derivative at a point. Our variable is time, or t. We're asked to find the velocity when t equals 5, and our function is cos of 4t. We get an answer of negative 3.6518 centimetres per second, which aligns to option D. Most students did pretty well on that question. So, question 2. The question defines the function f of x equals x by e to the x and seeks information about the derivative f dashed of x and the second derivative f double dashed of x when x equals negative 1. Both of these calculations can be done relatively easy by hand or on the calculator. There are a number of ways we can do this on the calculator. The first thing I will do is insert another problem. While this is not necessary mathematically, it makes things much easier if we need to go back and review a previous question. For this question, I'll use the calculators menu and select derivative at a point. The variable is x, where x equals negative 1. I'm going to start by calculating the second derivative. We get an answer of 0.3678, etc. So f double dashed of x is greater than 0. Options A and C are now both out. Now, I could go back to the menu. Alternatively, I can copy and paste the previous calculation and just change the first derivative. And we get f dashed of x equals 0. So the answer is option B. Only 60% of students got this question correct. Given the calculator approach was particularly straightforward, one can only assume it was a notation that caused problems. So the takeaway from this question is familiarise yourself with the various forms of notation for both functions and calculus. Question 3. Most students really struggled with this question, so we're going to take a bit of a deep dive. We're asked to determine the number of points of inflection. However, we're not provided with the original function, rather the derivative, so we can't simply look at the graph and do a visual inspection. More on that later. So to start, let's look at what we are required to know about points of inflection. The course tells us we need to understand the concepts of concavity and points of inflection and their relationship with the second derivative. We are looking for changes in concavity for our function. Insert a new problem, insert a graphs application, and graph the derivative given in the question, sine of x cubed. Next, adjust the window settings. Use the domain provided in the question as a guide to your window settings. And we see there are 4 turning points, indicating that there are 4 points of inflection on the original function. For the first turning point, the gradient function changes from increasing to decreasing. The second turning point tells us that the gradient function was decreasing and is now increasing. But we do need to be careful about what's happening here at the origin. To the right of the origin, we have 2 more turning points. The first one tells us that the gradient function was increasing and is now decreasing, and the second one tells us the gradient function was decreasing but is now increasing. So, what's happening at the origin? The definition provided in the course outline advises us to look at the second derivative. It's easy to graph the second derivative. So now we get a better picture of what's happening. The turning points on the derivative function align with the second derivative crossing the x-axis. When I say crossing. At the origin, the second derivative does not cross the x-axis. If you would like to gain a deeper understanding of the points of inflection, specifically pertaining to this question, check out our other video all about points of inflection. For the purposes of this video, we can conclude that since there are 4 occasions where the second derivative crosses the x-axis, then there are 4 points of inflection on the original graph of f of x. So the answer is option C, 4 points of inflection. So the takeaway from this question is that whilst you have a very powerful mathematical tool in your hands, you still need to have a good understanding of the underlying mathematics. Question 4. We're provided with the mean of a sample proportion, 0.15, and the standard deviation, 0.0345, and asked to find the sample size n. For this question, we can just jump straight into a formula. We know that the standard deviation is equal to the square root of p times 1 minus p all over n. So we can either rearrange this formula to make n the subject or just use the nsolve command. Both operations are just as quick. I'll use nsolve of 0.0345 equal to the square root of 0.15 times, some mental arithmetic, 0.85 all over n, and we'll solve that for n. We get an answer of 107.12, which aligns to option C, and almost 80% of students got that question correct. Question 5. Less than 40% of students got this question correct, with almost the same number of students choosing the same incorrect answer. So we will look at a slightly different approach to answering this question, a way that will help avoid the mistake made by a significant proportion of students. We are provided with a piecewise definition for a continuous probability density function. The calculator is more than capable of defining it so. However, this is a multiple choice question. We are only using the definition for this specific instance, and so the integration terminals in the calculation of the expected value make the full definition superfluous. So in the interest of saving time, I'll define the function f of x equal to cos of x all over 2. We're asked to calculate the standard deviation, which we can find by calculating the square root of e of x squared minus e of x all squared. I'm going to define e of n as a numerical integral between negative pi on 2 and pi on 2 of x to the power of n multiplied by f of x. Now I can calculate the square root of e of 2, which is the expected value of x squared, minus e of 1 all squared. And I get the answer 0.684, which is option B. So why did so many students get this answer incorrect? Why did they choose option A? Well, it turns out option A is the variance. So let's see how students most likely calculated this. We can calculate the expected value of x and we get 0. Now we calculate the expected value of x squared. And here's the problem. The answer of 0.467 is one of the options. Students' brains were essentially hijacked by recognising this result amongst the multiple choice options and therefore immediately bailing out of any subsequent calculations and erroneously selecting the variance. By defining e of n, where n can be used to calculate e of x squared and obviously e of x, we've only ever seen the result for the standard deviation. Question 6. In this question, we are told that the volume of lemonade is normally distributed, a mean of 60 ml and a standard deviation of 3 ml. We want to find the volume, let's say x, for which 80% of cups will contain more than x. We can do this question without using a calculator. Draw a diagram and estimate a value for x for which 80% of the graph will be shaded to the right, that is, greater than x. From our graph, it should be clear that the value for x must be less than 60. That cuts out options C and D. However, almost a third of students chose option D, an option which we have eliminated by drawing a simple diagram. We can go one step further. 68% of the volumes lie within one standard deviation of the mean, so 16% lie below one standard deviation and 16% above. We can therefore see from our diagram that approximately 84% will lie above a value that is one standard deviation below our mean. That is, 84% of the volumes will be above 57. So the answer must be option B. So why did so many students choose option D, an option that is clearly wrong from our diagram? If we calculate the inverse normal using the calculator, inverse norm 0.8, 60 and 3, we get an answer of 62.5. Just like the previous question, our brain has been hijacked. A value on the calculator resembles one of the answers. Some people refer to these as trick questions, but they are not. Common mistakes occur in everyday life. It's why they are called common. Your job is to find ways in which to avoid them. The calculator is a very powerful mathematical tool, but it's called a calculator, not a thinkulator. So don't try and use it to avoid thinking. Traditional problem-solving techniques, like drawing a diagram, are still 100% applicable. Question 7. The equation in this question is for the velocity. We need to determine the distance travelled in the first 4 seconds. The question states that the object, a marble, moves in one direction. So in this instance, we don't need to concern ourselves about the marble potentially changing directions during our time, and therefore performing multiple integrals. We can also see from the velocity equation with t greater than 0, the logarithm will be greater than 0 for t greater than 0. So, we can simply calculate the numerical integral from 0 to 4 for our function. We get an answer of 8.09, etc. The units match, so therefore our answer is option D. The most common mistake in this question was students choosing option C. See if you can figure out what mistake these students were making. Using past exams in this way, working backwards to figure out common errors, will actually help you avoid doing something similar in the future. Question 8. This is another question where we should be able to answer the question just as quick with or without a calculator. A logarithm, base 9, just like any other logarithm, say base 10 or e, will have a vertical asymptote when x equals 0. The function has been translated 3 units in the positive x direction, so the asymptote will be at x equals 3. Just to be sure, we can draw a graph and now draw a graph at x equals 3. Now we have some visual evidence to support our answer. Option C. Question 9. Another interesting question. We know that the longest side of the triangle will be opposite the largest angle. Side AC is therefore the longest side. Side AB will be the second longest side as it is opposite the second largest angle. So side AB must be bigger than BC. Furthermore, angles ACB and CAB are relatively close to one another at 37 and 30 degrees respectively. So our triangle is, I guess, a little bit like an isosceles triangle, just not quite. So the side length must be approximately the same as side BC. So our answer is most likely to be option B. At the very least, we have an estimate, a value that seems logical. To check our answer and calculate the length, we can use the sine rule. We could use the NSolve option, however, for this question there is only one value that needs to be transposed. So we can calculate 12 divided by the sine of 30 degrees multiplied by the sine of 37 degrees. As my calculator is currently in the radian mode, I could swap across to degrees for this question, or just add the degree symbol to each angle. We confirm the result of 14.44 being option B. We could also have done this question using the geometry application. However, that would take a bit more time. Now see if you can figure out why so many students chose option D, a common error. Once again, being aware of common errors will help you avoid them in the future. Question 10. A relatively straightforward question with most students getting this question correct. It's also another question where we can do well just by estimating. If we say that E is relatively close to 3, and we know that 3 cubed is 27, it would be reasonable to conclude that 2x minus 3 needs to be perhaps just a bit bigger than 3, which immediately eliminates options A and B. If we make x equal 4.54, then 2x minus 3 is approximately 6, and 3 to the 6 is much bigger than 42. So at this point, we could simply substitute x equals 3.37 and check our answer. Or we could graph it, or use the solve option. We have a one-to-one function, so there is only one solution, and we get a result of x is approximately 3.37 and choose option C. That concludes all the multiple choice questions. A good exam technique is always to check your answers. You'll have noticed that throughout this video, I've created a new problem for every question, so you can quickly and easily go back and check the calculations performed for every single one of those questions. That concludes the multiple choice section of the 2022 QCAA Methods Exam Technology-Active. Check out our other videos, Solutions to Short Answer section of this exam, and another one with an in-depth review of question 3 pertaining to points of inflection. And in the words of Dr. Seuss, sometimes the questions are complicated and the answers are simple. Catch you next time.